Good morning, students of Prep 2, St. Joseph School. Today we're going to talk about Unit 2, Lesson 1, which is called the atmospheric layers. First of all, I think you know that the Earth is like that, and the Earth is surrounded by a gaseous envelope, mixture of gases, and this mixture of gases together is called the atmospheric envelope. So what's the atmospheric envelope? It's a gaseous envelope that rotates with the Earth around its axis. When the Earth rotates, this gaseous envelope rotates with, and it extends 1,000 kilometers above the sea level. The distance between the sea level and the last point of this atmosphere is about 1,000 kilometers. For sure, this mixture of gases have weight. And due to this weight, it causes something called the atmospheric pressure. So what's the atmospheric pressure? It's the weight of air column per unit area. The measuring unit of this atmospheric pressure, we can measure it by bar, or we can measure it by millibar. If you know that, 1 bar equals 1,000 millibar. The normal atmospheric pressure at the sea level equals 1013.25 millibars, and the device which is used to measure this atmospheric pressure is a device called barometer. This device has two types. The first type of barometers is called aneroid, and this aneroid it's used to determine the possible day weather. If the weather is rainy, or maybe it's stormy, or maybe it's sunny, and too many other cases. The second one is called altimeter. And this device, it is used by pilots to determine if the altitude based on the atmospheric pressure. It's used in the airplanes to let the pilot know at which altitude this plane is flying off. There is an information that says the atmospheric pressure is affected by altitude. As the altitude increases, the atmospheric pressure decreases. If you have two persons, person A and person B, A is at the sea level and B is on a mountain, and you measured the atmospheric pressure for both, you will find that the atmospheric pressure of A is more than the atmospheric pressure of B. Why? Because B at higher altitude, and by increasing the altitude, the atmospheric pressure decreases. Also, the density of air decreases by increasing the pressure. 50% of the mass of air is found between the sea surface and altitude 3 kilometers. If the sea level, and this is 3 kilometers up, 50% of air is found in the first 3 kilometers, and at a height 16 kilometers from sea level to height 16 kilometers, 90% of the air is found. In order to express this atmospheric pressure on maps, we use some curved lines called isobar. What are these isobars? They are curved lines that join the points of equal pressure on the atmospheric maps. This is a point, this is another point, and here is a third point. This curved line join the points of equal atmospheric pressure, and this curved line is called isobar. If the area is high pressured, we write in the middle H. H stands for high. And if the area has low pressure, we write L in the middle, and L stands for low atmospheric pressure. And this helps us to know the direction of the wind, as the wind moves always from the areas of high atmospheric pressure to the areas of low atmospheric pressure. Now, we're going to classify the atmospheric layers into 4 layers. The first one, it's called troposphere, or the disturbed layer. It's the first layer of the atmospheric envelope. And it means disturbed layer. Disturbed, it means it has a lot of disturbances, because all the atmospheric phenomena, all the atmospheric turbulences, like storms, like rains, like clouds, they happen or they take place in this layer. Thickness, it extends from the sea level up to 13 kilometers. From here, from the sea level, starts at the sea level, until we reach a line called tropopause, and this thickness is 13 kilometers. It contains 75% of the mass of the air. So 75% of air mass is found in the first 13 kilometers in the troposphere. That's why all the atmospheric phenomena, all the weather conditions like storms, like clouds, they happen or they take place in it. What about the temperature? The temperature decreases by 6.5 degrees for each 1 kilometer up. If the temperature at the sea level, for example, is 20 degrees, and then you moved up just 1 kilometer, the temperature will decrease by 6.5 degrees. So the temperature is going to be 20 minus 6.5, it gives 13.5. So the temperature here is going to be 13.5 degrees Celsius, for example. So each 1 kilometer up, the temperature decreases by 6.5 degrees. What about the water vapor? It contains 99% of this water vapor, and this water vapor is very important in organizing the earth temperature. And organize means adjusting the temperature of earth. It doesn't make it so high or so low, but it just organizes it. The air movement in this layer is vertical, which means the hot air, it moves up. Why? Because it has low density. While the cold air falls down. Why? Because it has high density. That's why the movement of air is vertical. This is everything about the first layer. Second layer, it's called stratosphere. And this stratosphere, it is the second layer of the atmosphere, and it's called the ozonic layer. Why? Because it contains the ozone layer. What about its thickness? It extends from the tropopause. Let me explain on this picture. This is the stratosphere. This line is called tropopause, and this line is called stratopause. So the stratosphere is between the tropopause and stratopause with a thickness of 37 kilometers. The temperature at the lower part is -60. At the tropopause, it's -60 degrees Celsius, and it keeps increasing gradually until it reaches zero at the end of this layer. Why? as the ozone layer absorbs these ultraviolet rays, which makes the temperature increases. So at the tropopause, the temperature is negative 60, and up is 0 degrees Celsius. So it's clear that the temperature increases as we go up due to the presence of the ozone layer, which absorbs the ultraviolet radiations. Atmospheric pressure decreases and reaches above this layer is about 1 millibar. So the temperature here is 0 and the atmospheric pressure is about 1 millibar. It contains the ozone layer. That's why we named it the ozonic layer, and it's found at a height from 20 to 40 kilometers. And the lower part doesn't contain any clouds or weather. That's why the air movement is horizontally, and that's why the pilots prefer to fly in this layer. Third layer, it's called the mesosphere. And the mesosphere, it means the middle layer. If we said that this is the sea level, and here is tropopause, this is troposphere, and this is stratopause. So this area is stratosphere, and this dotted line, it's called mesopause. That's why we said the mesosphere layer, the coldest layer, it extends from the stratopause till the mesopause with a thickness about 35 kilometers. And it's called the coldest layer as the temperature at its top reaches about negative 90 degrees Celsius. So it's called the coldest layer. What about the atmospheric pressure? It keeps decreasing until it becomes 0.01 millibar. And it just contains a limited amounts, a very small amounts of helium and hydrogen gases. That's why we name it the highly rarefied or the highly vacuumed layer. This layer, it contains the meteors. The meteors are found due to the friction with the air particles. And this is everything about the mesosphere. The last layer, it's called thermosphere. It's the fourth layer, and it's called the thermal layer as it's the hottest one. The temperature at the end of the thermosphere, it reaches about 1200 degrees Celsius, and it's a very, very, very wide layer. Its thickness is about 590 kilometers. The last part of this layer, it's called the ionosphere. Why? Because it contains some charged ions. This ionosphere, it's a layer that contains charged ions, and it has an important role in wireless communication. Like, this is the last part of the ionosphere, and this is a person is talking in the mobile phone or something. These devices or these radio stations send some wireless waves. It hit the ionosphere, then it comes back. That's why it's the ionosphere layer is very, very important in wireless communications. We have something else called the Van Allen belts, and they are two magnetic belts that surrounding the ionosphere. Around the ionosphere, we have these Van Allen belts, and they help us in protecting us from the harmful charging cosmic radiations coming from the space. These colors that we can see in some movies, it's called aurora phenomenon. And this aurora phenomenon, it happens because Van Allen belts scatter or reflects back the harmful cosmic radiations coming to us. And we can see this phenomenon only from the two poles. Last part of the atmosphere, it's called the exosphere. And this exosphere, it's the region in which the atmosphere is inserted with the outer space. And it's the place where the satellites revolve around the Earth. So the importance of exosphere is that it contains the satellites that revolve around the Earth. Also, these satellites are used to transmit weather conditions and TV programs. Last part of our lesson is how can we calculate the temperature at any height. If you need to calculate the temperature at a height, you have this rule: temperature at sea level minus 6.5 times the height, and the height, it should be in kilometers. Let's read this problem. The problem says, calculate the temperature at a height 7 kilometers if the temperature at sea level is 20. So we have to apply the rule. The temperature at sea level is 20 degrees Celsius minus 6.5 times the height. And you have to make sure that the height is in kilometers. If it's in meters, you have to convert it into kilometers. So if we read the problem, the height is 7 kilometers, so no problem. And then we calculated 20 minus 6.5 times 7. It gives about negative 25.5 degrees Celsius. If you need to calculate the temperature at sea level, we have to use the second rule. Calculate the temperature at sea level if the temperature at height is 9 kilometers. At 9 kilometers is 25 degrees. So, temperature at height h is 9 kilometers. Is 25 degrees Celsius plus 6.5 times the height is 9. This is negative 25. And we calculate the temperature in Celsius. Last kind of problems, if you need to calculate the height. Calculate the height if the temperature at the height is negative 45 and the temperature at sea level is 20. So we use the third rule, the rule of height. The temperature at sea level is negative 45 degrees Celsius. Now the temperature at sea level is 20 minus the temperature at height is negative 45 over 6.5, and then you use your calculator to calculate the result in kilometers because you are calculating height. And this will be everything about lesson 2, and see you in another lesson.